World. Now we're going to talk about one of the most important algorithm in quantum computing, which is a Grover algorithm. And this is done by Love Kumar Grover from Stanford University. What is Grover algorithm? It's a quantum search algorithm, offers quadratic speedup instead O(n). O(n) it offers O square root of n. How it works? It follows 4 steps, create superposition of all possible states, oracle, amplitude, and then measure the quantum state. For example, if the key solution is one of these boxes here from 0 to 90, maybe one of those, the classical computer go one by one, search. If you're lucky, the first one. If not, if you're not very lucky, the last one, but it could be in the middle. So go one by one sequentially. With the Grover's algorithm, it takes time O(n) because the sample is n. And Grover take O square root of n. Like if you have a million box to search, and we know in big data you have a lot, then it takes you, let's assume, 1 minute each. So 1 million minutes here square root, it will be 100 minutes. Another example here is example of O(n). If you have n items, you want to search it in a classical way, in a Grover's, it will take you a square root of n. How Grover's work? This is an AI generated. I asked it to do it. It's worked through a complex number, and it's rotating. One way to think about it, the square root coming from, if you have a Pythagoras theory, a squared plus b squared equals c squared. The square root of c squared. So if you want to go from this point to here, with the classical, you have to go here and here. But with the quantum, you go straight. That's one way to explain it. This is not exactly what happened, but this is one way to explain from where the square root comes. Where the square root comes from, Grover's, I just said, from n square root m. For the Pythagoras theory. Application in finance, portfolio optimization. We use a lot of Grover's algorithm. We will use, not using now. Now we're not using, but we will. Arbitrage. It's very hard to get arbitrage, but now with the quantum, you can have a lot of arbitrage. Fraud and efficiency. Grover versus classical search. We talked about, for example, if you have 1 million steps in a Grover, it take square root of 1 million will be like 1,000. Visual Grover quantum circuit, initiate a qubits, the superposition, followed by applied Grover diffusion, then Qiskit example, oracle and diffuser, apply oracle and repeat. Grover algorithm purpose is unstructured search. Shor's algorithm purpose integer fractions. This is other algorithm. Speed is exponential. Quantum frontier transform is foundation from many algorithm, not useful by itself, but critical for short routine. Grover's in finance, portfolio optimization, goal, finance optimal. Along this, Grover and Oracle and quantum circuit boost valid portfolio probability and potential speed up. The homework is the questions here. How does Grover algorithm improve upon classical search? It's like O(n) versus square root of n. What are the key steps in Grover's? We have 4 of those. What are the main limitations and practical application for Grover? Thank you so much, and I hope you learn one of the most, if not the most, algorithm in quantum computing.